100 is 4 in binary. 101 is 5. 110 is 6. 111 is 7. Now you got it. Now you understand you can count in binary, and it works exactly in the same way that it does with the decimal system. Exactly the same rule. Now, if I was going to ask you a simple question, which is, tell me the highest number that you can write with three decimal digits, you immediately would say 999, because you're so used to that system, you don't even think about it. 999. Big deal again, right? Well, look, there is the practice and then there is the theory. How can we express that for our friend the Martian and tell him, look, there are rules to our numerical system and we know those rules, and we can express what I just said by words in a mathematical way. So bear with me, it's important. How can we mathematically write the rule that defines what is the highest number given a certain number of digits in a certain type of system? There is a very, very simple rule, nothing complex, anybody can understand this, okay? So first of all, we write the number of symbols that we have in our numerical system. If we're using the decimal system, we have from 0 to 9, 10 digits, so we write 10. Then we add the power equivalent to the number of digits, so 3, 10 to the power of 3. And then we subtract the result with 1. We do minus 1. So 10 to the power of 3 minus 1. So 10 times 10 is 100. 100 times 10 is 1000 minus 1, 999. Exactly what we said before. And of course you're saying, well, big freaking deal, I can do that without thinking. But that is the mathematical rule. What is important here is that we have multiple numerical systems. There is the decimal system and there is the binary system. Now, the computer cannot understand 10 symbols. It can only understand 2 symbols. So now we verified that we can count. So, okay, if I have a computing machine, a machine that can use just the binary symbols, can I count? Can I express numbers? Yes, because I can count in the same system. Now, if I have that machine, are all the laws, the mathematical laws of the decimal system moving to the binary system? And it has been demonstrated that they do. So let me show you one thing. I'm gonna ask you the same question. Given 3 digits in the binary system, what is the highest number that you can express there, that you can write there? What is the highest number that you can write with 3 binary digits? So we use exactly the same system. We write 2, because that's the number of symbols, to the power of 3 minus 1. 2 times 2, 4. 4 times 2, 8 minus 1, 7. 1, 1, 1 is 7, as we demonstrated before when we were counting. 1, 0, 0 is 4 in binary. 101 is 5. 110 is 6. 111 is 7. So now we have solved everything. We have a different numerical system that works, we can count, and we see that the same rules of math apply from one system to the other. Fantastic. Now, this should have given you a hint of why, when you buy a telephone, you buy a telephone with a memory with storage of 32, 64, 128 gigabytes. Because everything in computers is now expressed as a power of 2. In the decimal system, because we are using 10 symbols, everything is expressed as powers of 10. So 10, 100, 1,000, 10,000, and so on. With the binary system, everything is the same, but this time is a power of 2 because that is the base of our system. So 2, 4, 8, 16, 32, 64, 128, 256. All right. So here comes. Here comes the real deal. Back in the day, the people who designed computers decided that working with bits, because a binary digit, 0 and 1, is a bit. Okay, binary digit, abbreviated to bit. Working with bits was not really practical. So what did they do? They clustered them together, they grouped them together, and they decided that the minimum unit we would generally handle is a collection of 8 bits. And they call that a byte. B-Y-T-E, byte. So 1 byte is 8 bits. And again, if you're asking why not 10, again, because we are working in powers of 2. So 2, 4, 8. 2 was too small, 4 was still small, 8 is a good unit. Now, if I was going to ask you, what is the highest number that you can write with 8 binary digits? You would immediately start writing 2 to the power of 8 minus 1. So let's do it. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. 128 times 2, 256. Minus 1, 255. Now you know why in Photoshop you're expressing color using numbers from 0 to 255. Didn't I tell you it would make sense? Now you know, because every single pixel is expressed, is represented using 1 byte for red, 1 byte for blue, 1 byte for green. And that is how we define digital images with a computer. It's all numeric, it's all base 2, and that is why we have 256 values for every RGB channel from 0 to 255. That's 256 values because 0 still matters. 0, 0, 0 is pure black. Now, if you wanted to create a gray color in nature, as we see it, the same in the computers and the same in nature, is when all 3 values are the same. When red, green, and blue are exactly the same, we perceive that as gray. And when it's really bright, it's pure white. So pure white is 255, 255, 255. Pure black is 0, 0, 0. If I want to express a gray, I'll continue using those 3 numbers at the same value and going from 0 up to 255. So for example, a rather dark gray will be something like 50, 50, 50. If I want to use a medium gray, well, I just have to divide 255 by 2. And that's 127, 127, 127 for all 3 channels. So that's your medium gray. And now you see how, for example, if I wanted to create a color with these numbers, that is what I get. And if I wanted to make that color twice as bright, I simply double those numbers. And now we see how we can create actually mathematical operations on colors. Wow, what a concept. Why? Because everything in a computer is numerical, because this is the meaning of the word digital. This has been a long lesson. Thank you very much for sticking around and for watching it. I hope it was useful. My name is Paolo with People's Tech channel. Please remember to subscribe and click on the bell so you will get notifications for new videos. Again, thank you for watching. See you next time.